One-way ANOVA with SPSS. ANOVA stands for Analysis of Variance. Case 1. 3 different types of drugs were used to ease level of migraine among some patients. Drug 1 was administered to 11 patients, while drugs 2 and 3 were administered to 10 patients each. The table below shows the times in minutes for complete relief of the migraine headache for each of the drugs. So you can see the table relief time for migraine headache for the 3 groups of patients. The first group were administered with the drug 1. The second group was administered with drug 2, while the third group was administered with drug 3. And we can see the relief time, 6 minutes for the drug 1. We have 6 minutes, 7 minutes, 5.5 minutes, 8 minutes, 6.5, 9.5, and so on and so forth. We can also see same for drug 2. These are the relief time in minutes. And then drug 3, the relief time in minutes also. Now, what we want to find out now is to ascertain whether the average relief times for the 3 drugs are the same or otherwise. Now, I think we need to, first of all, make it easy for us. I want to move this to a spreadsheet. We want to use SPSS to do this. So I'll copy this. Let me move it to Excel. Paste it on the first cell, and it spreads out the way you have seen. Now I want to rearrange it here because we need the information here to be in just 2 columns. From our previous lesson, variables should be in columns. So there are 2 major variables involved here. The first variable is drugs or drug, and the other variable is relief time. In line with the levels of measurement or principles of measurement, there are 2 categories, there are 2 levels of measurement applicable here. Drug is categorical in nature. So that falls under the nominal level of measurement. And then relief time is ratio data. Remember, we have the nominal, ordinal, interval, and ratio data or levels of measurement. Now, because we have one variable which we categorize as relief time, another variable we categorize as drug, which will be drug 1, drug 2, and drug 3, 3 categories. So that's nominal. We are going to move this into, want to rearrange this so we're having just 2 columns. Now to do that, I'll just rearrange this. I'll cut this. So I delete this. Now this is drug 1. 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. I need to move this to the right place. I need all the information here to be in 1 column. So this is drug 2. And then the last one is drug 3. So this way, we can move it to SPSS. So I pick just this. I needed to simplify this before moving it to SPSS. So I paste. So what we have in variable 1, the column bearing variable 1 is the relief time, which is ratio level of measurement. And then the other one is the drug or drug type. And the condition for using one-way analysis of variance is you should have 1 factor, which is the one-way now. 1 factor. Factor here is a nominal variable or nominal data, while relief time is the ratio or interval data or interval level of measurement. So this is how it should be. If you are running a one-way ANOVA, there should be 1 factor, and there should be the 1 factor is at the nominal level, and then the other variable should be the ratio or interval variable. So now we'll need to rename this. Here we have data. We're on the data view right now. So we'll go to variable view to rename. Our first variable is relief. I call it relief time. Relief time. Well, I just leave it as relief time, TM. And then the other one is the drug. Now, because this is a categorical variable, we will need to relabel what we have here. So we won't apply that to the ratio data. It's only applicable to the categorical. So come to where you have your values. We are still on the variable view, and double click here. That's what I did. I moved just along the same row with the categorical. Just double click on this box. You see the ellipsis. This. So tap on the ellipsis. A value labels dialog box appears. Now, when that appears, you need to now assign labels to each of the values. Remember, we relabeled the drug into 1, 1, 1, 2, 2, 2. So we have 3 categories here. So the first value 1 represents drug 1. Here. The second one represents drug 2. And then the third one represents drug 3. So we add and click on OK, so you can see it has so that when we print out, when we get our output, we'll be seeing drug 1, drug 2, and drug 3, rather than seeing 1, 2, and 3. So I go back to the data view, and now we're seeing here, let me see. So this is relief time, the variable relief time, and then drug type, as the case may be. To run a one-way ANOVA in SPSS, you go to analyze. We're trying to compare means across 3 groups. The groups here are the drug 1, drug 2, and drug 3. So you go to analyze, come to compare means, and then move to the right and look for one-way ANOVA. It takes you to this dialog box, one-way ANOVA dialog box. Now, on your left-hand side, you can see your data, the information concerning relief time, and then the drug. Relief time is at the ratio level measurement. Drug type is at the nominal level of measurement. Now, a dependent list will be the quantitative or the data at the ratio or interval level. Relief time will come in here because it's at the ratio level. That's like your dependent variable. And then the drug will come to where you have factor. So you click it. You click the button and it takes the drug into factor. Now, we will run a descriptive statistics first. Now look at this. I click on options. I select descriptive and say continue, and then say OK. We want to find out whether significant difference exists or not. Now, these are descriptive information. So you can see now the code 1 is drug 1, code 2 is drug 2, while code 3 is drug 3. Now you can see that the various relief time range from 5.7 minutes to 7.45 minutes. So the first drug, the average relief time recorded here is 7.05 minutes approximately, 5.7 minutes and 7.45 minutes respectively. And then if we come to the ANOVA table, we'll see here that our significant value, the p value here shows that p is 0.015, sorry. And from the rule of thumb, we have 2 rules of thumb to determine whether significant difference exists between variables or among variables. The first rule of thumb would be the critical p, using the critical p value. If p is less than or equal to 0.05, then we reject the null hypothesis. If you are rejecting the null hypothesis, it suggests that there is significant difference across the groups. Alternatively, if p is greater than 0.05, we are accepting the null hypothesis that there is no significant difference between or among the groups. In this case, across the groups is what we're going to be looking at. Now, our p-value here is 0.015. 0.015 is less than 0.05. So the implication here is that there is significant difference in the relief time. Now, because we have established that there is significant difference, we need to run a further test known as the post hoc multiple comparisons test. If we do not find or if we do not establish significant difference, we don't have to go further. In that case, we'll just make our inferences with the mean values. We'll now look at the relative time. So we could just say drug 2, the relief time for drug 2 is 5.7 minutes, and then you have drug 1, 7.05 minutes, and drug 3, 7.45 minutes, which suggests obviously that the relief time for drug 2 was the least. So it took a longer time for drug 3, but it took a shorter time for drug 1, and that ends it there. But because we have established that there is significant difference, we'll close this and add a further test. This applies only when you establish that there is significant difference, which we have established from what we have found. So we'll go back to analyze and come to compare means. Go back again to Oneway ANOVA. We had already selected options where we selected descriptive. We had done that before. So the further test is to go to the post hoc button. Click on the post hoc button. There are several tests here you can do. We have the LSD, we have the Bonferroni, we have CDAC, we have SPSS, we have Duncan, we have Tukey. Well, the commonest one, LSD, SPSS, Duncan, Tukey. In subsequent videos, we'll discuss some of this, but I want us to look at Duncan. I click on Duncan, and then I say, okay. Now you see, in addition to when we ran the test earlier, we had this table, we had this table. But in addition to those two tables, we have a further table, the post hoc test homogeneous subset table. You can see that here. Now, it has now juggled. You can see it was initially properly arranged 1, 2, and 3. But it has now separated the means. You see it out now as 2, 1, and 3. So drug 2, the sample sizes, drug 2, we had 10 samples, that is 10 patients. Drug 1, 11 patients, and drug 3, 5 patients. Now, the relief time was separated into 2 subsets. Subset 1 in this column and subset 2 in this column. Now, for it to make better sense, I want to rename this subset 1 as A and subset 2 as B. So let me move this to another page so that we'll make it clearer. Now this is it. I want to draw a table. I just want to draw a different table here so I can explain. I'll be able to explain further what I mean. Let's do this. Okay. So I take this first one as drug, drug type, and sample size, and then relief time. So this is a table you'll be presenting in your results section. Relief time in minutes. So we have the way it is here. You can see the first drug is drug 2. So write it as we have seen in the Duncan. We're using the Duncan now. Drug 2, then drug 1, and then drug 3. Now the sample size for drug 1 is 10. Sample size for drug 2 is 11. Sample size for drug 3 is 10. Now, we'll move to the third column, the relief time in minutes. I said we're going to be changing this to A and changing this to B, just for ease of interpretation. Now, I put what we have there, 5.7. This is 5.7 minutes. in the first column, I move the next one so that they will all be in one column now. What you have here, and we have just one item here for the relief time. We have two other items. We want to bring all of them together so we can make our discussion easier. Then we'll have 7.04 or 7.05 approximately. This is this. And then the last one will be 7.45 approximately. Now, I said the first subset where we have subset 1, where we have this. So what we are going to be having beside this relief time will be A. Whatever we have here will be B. So I just do this. So beside here is subset A, and beside this is B, and this is also B, because 5.7 was under subset 1, which we are now going to be renaming subset A. 7.05 was under subset 2, which we are renaming subset B. The same thing with 7.45 minutes, subset B. Now below this, I don't need this table. I don't need this row. So let me delete that. I'll delete this row. Now below this, I need a footnote. Mean relief time with different subscripts. Is significant at 0.05 level. This is very important, because this is what will help the readers to appreciate what you are trying to explain. Now we want to interpret what we have just written here. This is actually our subscript. Subscript will be this. Oh, sorry, this is our subscript. Subscript. Fine. So I need to just maximize this. Cool. Now we are saying here that the mean, this is the relief time, and we have 3 sets of information here. Mean relief time with different subscripts. Are significant at 0.05 level. Now, what we are saying here is that this subscript will direct us to properly interpret the relief time. Now, what I mean here is that we have subset A, we have subset B, and we have subset B here. There's a difference because A is different from B. But there's no difference if you say B and B. There's no difference there. Now, using this to interpret, we'll simply write thus. The table shows that drug 2 recorded relief time of 5.70. Drug 1 recorded relief time of 7.05 minutes. Important to put that. Minutes. While drug 3 recorded relief time of 7.45 minutes. Now, from the findings, significant difference exists between drug 2. We'll now put in parentheses the mean of 5.7 minutes between drug 2 and drug 1 with relief time of 7.05 minutes. So also, significant difference exists between drug 2 with a relief time. Well, to make it easy, I'll just pick what I did before. This and drug 3. So drug 3 will be mean of 7.45 minutes. So what we're saying here is this: from the findings, significant difference exists between drug 2 and drug 1, which is what we're seeing here. Drug 2 is this, at this 5.7 minutes, and drug 1, because we have A and B. A is different from B, topically. A for the drug 2 is also different from B. In between drug 2 and 3, there's a difference also, because there are different alphabets or different subscripts. However, there is no significant difference in relief times between drug 1 and drug 3. So this is actually the results. This is our results. We have presented the results. Then we'll discuss discussion. Now, we want to discuss this. We have found that significant difference exists. Since significant difference exists between drug 2 and drug 1, this suggests that we can see that the relief time for drug 2 was far lower. This suggests that drug 2 had less relief time, indicating that drug 2, indicating that drug 2 was more potent in relieving or reducing the headache. Then here you need to corroborate your findings. I'll just give hypothetical. This finding confirms a previous research by 2019 who found or who reported similar results. A study by Jones 2020 also reported similar findings. So you can see we have discussed, we have presented our results, and we have also discussed our results. So this is how we'll present our findings. So you label your table. This is some post hoc multiple comparisons test. Duncan. Let's just leave it as Duncan. So Duncan tests. So this is our presentation. I hope you enjoyed listening to this video and watching, and I hope we'll be able to apply this in conducting one-way analysis of variance.